I see quantum computation as being a tool that can solve problems that you could never otherwise solve.
In doing genomic analysis to help find better drugs.
Debugging large, complex systems.
To looking for bad guys in large amounts of data.
Space exploration.
Trying to optimize waterworks.
Building artificial intelligences that can help us solve very difficult, complex problems.
Building a quantum computer is a historic thing. And it's really like venturing into uncharted territory. There's no precedent here.
Quantum computing literally taps into our most fundamental understanding of the laws of nature.
In nature, there's this almost spooky phenomenon called quantum mechanics, where a thing can be in two states at the same time. And so the D-Wave quantum computer uses that strange property. What the quantum computer actually does is it's able to compare many possible solutions at once. So if you imagine a regular computer, if it was searching for a solution, it would have to go through every possible solution one by one, see if that's a good fit. What the quantum computer does is it kind of lays all the solutions down and compares them all at the same time, so it can pick out the best one.
The D-Wave system is built to solve discrete optimization problems. These are types of problems where you've got a load of constraints and you're trying to find the optimal answer to your set of constraints. Say you've had some kind of natural disaster and you've got a load of people who need help, and you've only got a limited amount of resources to go help them. So you've got a few lifeboats and a few helicopters. And what you need to do is work out what order to send things and where to send things to save the most amount of people as possible. This is a hugely complex problem because there's so many possible different combinations of sending them in different orders. So this is the kind of thing that finding a fast answer is really important.
The D-Wave computer has two what I would say really sort of exotic operating conditions. We put our quantum processor into something called the dilution refrigerator, which cools it down to 10 millikelvin, which is about 100 times colder than interstellar space, and essentially is the coldest place in the universe. We have to also create an extremely low magnetic environment for the processor to sit in. That's about 50,000 times less than the ambient Earth's magnetic field. And so there are these two extreme conditions that the processor has to be run in.
In this company, a few dozen people in 10 years have managed to make a technology that can match and beat the existing normal computer technology that's been developed all around the world for 60 years.
We have an incredible future ahead of us. First and foremost, we're just going to increase the capability of this processor. We'll have at least 2 more generations of this processor over the next 5 years. So from a raw performance point of view, this is going to be an incredible capability. And will make a huge impact on the way things are done in this space of high performance computing and solving these really tough problems for humankind.